Hi everyone, and welcome to Integrated Math 2, your first homework assignment. So I will keep the time of these videos as short as possible. However, this year I'm going to try to do this every time, print out the problem so that it's in front of you, but I think you should have a couple of tabs open and be looking at the problem as you are doing your homework and not just watching me do a math problem and you really don't know what the question is. Also, you are expected to draw all diagrams, and if you need graph paper, I do always have graph paper at school that you can take home and use. But if you are missing a diagram or if it involves a graph and there's no graph, you will not get points. Okay, so we're going to start with 1-5, and it says to graph line MU. So I'm going to just look at these 2 points, and in my mind I'm kind of just thinking, okay, -1, +1, that's in quadrant 2. And then 4, 5 is in quadrant 1. So I'm kind of just mapping out how I'm going to use my graph paper. So I really just need the first 2 quadrants. Let me zoom out a little here. You can use a graph paper sticky. I have some of those at school. And those are small, so you do have to kind of be careful with those. But those are nice because then you don't need to use a whole entire sheet of graph paper. Okay, so we had these 2 points, -1, +1. And we have the point 4, 5. And we're going to draw the line going through those 2 points. A line goes on forever and ever to infinity without end. That's what those 2 arrows mean. If it didn't have the arrows, it would just be a segment and it would be stopping at those 2 endpoints. Okay, so calculate the slope of MU. Do you remember how to calculate slope? Hopefully you are a pro at this, and if not, let's do a quick refresher. So you can use a formula to find the slope, or you can just look at the rise over the run. If you draw a slope triangle connecting the vertical distance between those 2 points and the horizontal distance, there's your rise and your run. So the rise, I'm just going to count, is 1, 2, 3, 4. The run is, now be careful when you're counting. Some people make the mistake of saying 1 right here. This is actually 0. You're counting the squares. So this is 1, and don't get thrown off just because you're at the y-axis. That's 1, 2, 3, 4, 5. So the run is 5, and my slope, which is my change in y over my change in x. Change in y is your rise. So 4 over change in run is your run. Did I just say change in run? Change in x is your run. So 4 over 5. Could you use a formula? Absolutely. If you prefer to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm not really sure what you did last year, whatever way you wanted with me. If you were to do y sub 2 minus y sub 1, you're looking at the 2 y coordinates. So remember, this first number is your x coordinate, the second number is your y coordinate. So these are labeled x and y, and then it doesn't matter which one you make the first point and which one you make the second point. If I make this the first point, x sub 1, y sub 1, and this the second point, x sub 2, y sub 2, then y sub 2 minus y sub 1 would be 5 minus 1, which is 4. If I do x sub 2 minus x sub 1, I would have 4 minus negative 1, which would be 5. If you flipped it around and you made this the first point and this the second point, you would still come out with the same answer, because you would have 1 minus 5, which would be negative 4 on top, and then you'd have negative 1 minus 4 on the bottom, which would be negative 5, and you would wind up with negative 4 over negative 5, which would simplify to 4 over 5, positive 4 over 5. So I kind of did that intentionally to avoid having a lot of negatives, but it really doesn't matter. Okay, calculate the distance from M to U. So the distance from M to U is this diagonal length. The length cannot be counted. Some students every year will always say, well, I'll just count this way, miss. No, sorry, that doesn't work. You can count vertically, you can count horizontally, but not diagonally. And this is where your Pythagorean theorem comes into play. So we know that in a right triangle, when you draw a slope triangle, you are drawing a right triangle. We know that the sum, well, let's not put squared there yet. The sum of the two legs, sorry, the sum of the square of the two legs is equal to the square of your hypotenuse. C is your hypotenuse. Longest side is always the hypotenuse. So I'm going to set up a squared plus b squared equals c squared. So we know that the two legs are 4 and 5, so a and b are your two legs, so 4 squared plus 5 squared equals c squared. So that's going to give me 16 plus 25 equals c squared, which would be 41. I am not done. I need to solve for c. So the opposite of squaring is taking the square root. So if I take the square root of c squared, I get c. If I take the square root of 41, it's fine with me if you just leave it like this. I know it's somewhere between 6 and 7 because 6 squared is 36 and 7 squared is 49. It's fine with me if you just leave it like that. Okay, so this is the length, the distance from M to U. And this is the slope of MU. So the next question says, are there any similarities to the calculations that you used in part A and B? Any differences? Well, the biggest thing that you want to notice is that the slope is a ratio. It's the incline or decline of that line. The length of MU is a distance. It's the distance from one point to another on the coordinate plane. Okay, so if I have things on my paper, you should have them on your paper, so you might need to pause the video at some point. And I do expect you to listen to it, not just copy it without listening. Everyone is listening. And let's move on. Okay, this came out really, really teeny tiny, so I'm gonna zoom in a little. Okay, we are solving each equation, and I can't even see what that says. Let's see, let me look at the book. Okay, for 1, we're moving on to 1-7. So I try to pick problems. I'd love to do every single problem in the book, but I try to pick ones that are going to benefit you the most when it comes to SAT and when it comes to the test. And actually, all of it would benefit you when it comes to that, but there are some where we just have to make our choices. So for 1-7, we have x over 8 equals 3 over 4. And we're solving for x. So this is easy enough that you could probably just do it by saying what can I do to 4 to get 8? Well, 4 times 2 is 8. So then I'm going to do 3 times 2 to get x. So x must be 6. If you wanted to cross multiply and divide, you can. I'm always looking for an easier way to do it if I can. We will have to on some of these, I think, cross multiply and divide. So 2 over 5 equals what over 40? So I notice 5 is increasing to 40, and I'm going to ask myself, what am I doing to 5 to get 40? Well, 5 times 8 is 40. I'm going to do the same thing to 2. If there's an equal sign here, then this ratio is equivalent to this ratio. This is just more pieces of the pie. So I'm going to do 2 times 8, and x equals 16. Okay, we've got one that's not quite as easy because maybe I don't know what to do to 8 to get 12. And these will never be adding or subtracting because you're showing that 2 ratios are equivalent. That means that you're going to be multiplying this term to get this term or dividing. So let's just cross multiply and divide. When we cross multiply, we get 8 times x equals 1 times 12. So the cross products of 2 equivalent fractions will always be the same. So I know this times this is always going to be this numerator times this denominator. And then it's just an algebra problem. 8 times what is 12? Well, undo your multiplication by dividing by whatever's being multiplied by x. So that gives me 12 over 8, which reduces to, remember these are both divisible by 4. So if I do 12 divided by 4 and 8 divided by 4, I get 3 over 2. Or you could write 1.5. Okay, D is x over 10. Same process, 12 over 15. Let's just cross multiply and divide. Not quite as easy on this one, so we get 120 equals 15x. Divide both sides by 15, so x equals 8. Okay, our next problem involves a diagram. Angela has a rectangular piece of paper and she cuts a rectangle out of a corner shown at right. What are the area and the perimeter of this shape? Okay, let's see. I'm going to pause the video so I can quickly sketch. Okay, so I do expect you to sketch this on your paper. Colored pencils come in handy here. Now, it said she had a rectangular piece of paper, so she had a rectangle. And we're trying to find the area and the perimeter of what's left over after she cuts out this rectangle at the corner. So I could do this several different ways. We could split it up, or we could find the area of the rectangular piece of paper that she started with and subtract what she cut out. It's up to you. I'm going to do what I just described. If you want to do it differently and just check your answer, that's fine. So the area of the paper would be the base times the height, which would be 21 times 16. So I'm going to get that area and I'm going to subtract the area of the rectangle that she cut out, which means I need this base, this length, and this width, this height. So to get this length right here, I'm going to take this length, 21, and I don't want this amount right here, which is 6, so I'm going to do 21 minus 6, and that gives me 15. Okay, same process for the height. I'm going to take a new pencil. So I'm going to take the length of this entire side, which is 16, and subtract this little piece right here, which is, oh, sorry, I want to subtract this little piece right here, which is 9, to get this piece. So I'm going to do 16 take away 9, which would be 7. So the area of my rectangle that I want to subtract is 15 times 7. So that's going to give me oops, forgot to put parentheses. Although, I guess I really don't need parentheses here because it's going to multiply. Well, it might do that subtraction before it multiplies by 7. So let's put those parentheses in. So 231 is what I got. Let me check and make sure that's right. Yep. So my area is 231 square centimeters. And the perimeter is, now we want the perimeter of the cutout, so it's just going to be all of these sides added together. So let's see, 16 plus 21 plus 9 plus 15 plus 7 plus 6. When I'm adding, I mean, I could just put this in my calculator real quick, but you could just do 16 and 21, that's going to be 37, 9 and 15, that's going to be 24, 7 and 6, that's going to be 13, 37 and 13, that's going to be 50, plus 24, 74. So my perimeter is 74. Okay, now we are going to shift over to problem 1-103. So every chapter is going to have chapters, and that means you're expected to know how to do it at this point. If you don't know how to do it at this point, we're going to practice a little bit as we go along through each homework assignment. So this is kind of a long problem. It may take another 13-15 minutes for me to explain it, just to give you a heads up. But this is in lesson 1.3.3. If you're looking at the ebook, go to your lesson 1.3.3, pull up this problem, and let's work through this, because there's going to be problems like this on other tests. And you don't want to wait until the last minute to say, well, I didn't really learn how to do that last year. You want to make sure you're ready by the time you get to that. Okay, so each of these problems are separate. It says to write and solve an equation for each of the following problems. In the last election, candidate C received 15,000 fewer votes than candidate B. If a total of 109,000 votes were cast, how many votes did candidate B receive? So this would be a good place to kind of say, let me see if I can do this, and then pause the video, try it, and then watch and see if you did it correctly. So if you want to do that, go ahead and pause the video right now. If not, if you're totally confused, one thing I like to do when I'm doing a word problem is make sure I reread it. In the last election, candidate C received 15,000 fewer votes than candidate B. So who got more votes, C or B? C received fewer than B, so B got more votes. So candidate C got 15,000 less than B. So I'm going to write B minus 15,000. That's how many votes C got. If a total of 109,000 votes were cast, so C and B together got 109,000. Okay, well that tells me the amount of votes for B and the amount of votes for C. Okay, so we know that candidate B and C together got 109,000 100,000 votes, and we just need to figure out how many votes did candidate B received. Okay, well this is just a simple substitution problem. Do you remember substitution? This is already set up perfectly, so I'm going to switch out C and write B minus 15,000. Okay, and then I'm going to bring down this B, bring down this plus sign. I'm not going to use C because if I have a variable with if I have an equation with two variables, that's an infinite number of solutions. But if I have an equation with one variable, then I have one solution, which is what we have. We have one variable, B. It's written twice, but this is an equation in terms of one variable. Okay, easy enough. Let's combine like terms. 2b minus 15,000 equals 109,000. Let's add 15,000 to both sides. What's that? 124,000. And then divide by 2. So B equals 62,000. Okay, let me sharpen my pencil. Okay, our next question says that the price of gourmet coffee beans at the coffee market has increased 10% per year over the past several years. So when you see something with a percentage, that usually means you're dealing with exponentials. If the current cost is $14 a pound, what did a pound of gourmet coffee beans cost 2 years ago? Okay, so currently $14 a pound. Now, if you haven't mastered exponentials or linear equations for that matter, there is an entire section in the back of the book that has practice with this. I'm going to incorporate as much as I can into homework, but that's a great way to practice because it gives you the answer. You can check it. Maybe I'll do a video just for that, just for extra practice with linear and exponential. Okay, so I'm going to explain this kind of slowly. If you're like, I know how to do this, miss, and I don't need all that, feel free to skip over this explanation, but if you are a little shaky on exponentials, don't skip it, okay? Because this is not something you want to like feel, oh, I don't know how to do that, I never figured that out, and then you're going to not get it right on the test because you're not going to be able to like rush it. Okay, so the price increases 10% per year. I know that's really small, but hopefully you've got that extra tab up. So I'm going to just think about this. At year 0, the price is, I'm just going to call it A. After year 1, it goes up 10%. So it's going to be A plus 10% of A. So to get 10% of A, I'm going to multiply 0.10 times A. 10% as a decimal is 0.10. If I multiply that by A, that gives me 10%. If I add that to the original price, I get, remember this is 1A, so that would give me 1.10A. Year 2 goes up another 10%. Okay, so now I have to take this amount, 1.10A, and add 10% of this. So that's going to be 0.10 times 1.10A. Okay, now that would give me the answer, but what I'm going to do is, you see how I have 1.10A here and here? I'm going to remove that from both of those terms and write this differently. So 1.10A times 1 plus 0.10 is the same as this. It's just written differently. Well, 1 plus 0.10 is 1.10. So I get 1.10 times 1.10A. A, which you're probably wondering, why are you doing all of this? It's just to show you where that exponential model comes from. So 1.10 times 1.10 is 1.10 to the second A. Now, if you're confused on any of this, you can just memorize the formula. Yes, you can do that, but I think it's good to understand where the formula comes from. So I'm happy to go over this with you like one-on-one, maybe after school. It doesn't have to take a long time. Or don't be upset if you don't get things right away. Sometimes it just takes extra practice, okay? The Broncos start practicing very early, and they don't just practice once. They practice, what, every single day, right? It takes time to master things and to get better at things. Okay, so year 2, this is the cost of the coffee. Now, I could do another example like this, but you might be able to guess already. And I'm going to go quickly because I know this is kind of getting long. Year 3, I'm going to take this price, 1.10 to the second power times A, and I'm going to add 10% of this. So that's going to be 0.10 times this, 1.10 to the second times A. Now, I'm going to rewrite this. I've got 1.10 to the second times A here and here. So I'm going to factor out that common term. That's going to give me a 1 here because this times 1 is this. And then 0.10 here because this times 0.10 is all of this. This is 1.10, 1 plus 0.10, and this is 1.10 squared times A. Do you see where this is going? 1.10 squared times 1.10, isn't that 1.10 to the third power times A? Did you guess what that was going to be before I even did that? If you did, good job. You're seeing the pattern. Year 3, this is the price of the coffee. So let's write a formula for the price of this coffee. For year X, it's going to be 1.10 to the X times whatever that original price was. Now, when you saw this last year, you may not have seen it like this. You probably used it as a template. A is your starting value. B is your multiplier. And this happens to be an increase. Same thing's going to work for a decrease. Okay, let me get some more paper. So some of you are probably saying, I know that this is the formula. I'm just going to plug things in. That's fine. There's nothing wrong with that. I just want to make sure that you're good and you understand it. So my starting value, that's what I'm trying to figure out. I'm trying to figure out the price of the coffee. What's the price of the coffee? If the current cost is $14 a pound, what did a pound of gourmet coffee beans cost 2 years ago? So we're trying to figure out the cost from 2 years ago. Okay, so we don't know what A is, but we know that this multiplier is 1.10. It's increasing by 10%. If it's an increase, it's going to be 1 plus whatever that increase was. Here it was 1 plus 0.10 because it was a 10% increase. Okay, and then I'm going to put X. X is the time, and in this case it's in years. And then Y is going to be our cost in dollars. Now it's 2 years ago, so I'm not going to use a positive 2, I'm going to use a negative 2. And the cost actually, I was saying that I'm solving for A. I'm solving for the cost for 2 years ago. I know that the cost right now is $14. So sorry, that should have been a 14. So now we're just going to put -2 in the place of X for 2 years ago. Now, if you don't have a graphing calculator at home, we can come up with some ideas. I believe there's something that you can use online, and I can put a bunch of stuff out there to send you. You could probably find something on your own pretty easily, but we do want to have something you can use at home where you can do a type of problem like this. Okay, that's how you would type that in, the calculator. So it appears the cost of the coffee 2 years ago is about $11.57. Okay, now the next problem, I am not going to take that much time, but this is a really good reference. You might actually not have had time to like listen to all of that, but maybe you could come back to it and go through it a little bit more slowly so that you remember where that exponential template comes from. Okay, part C. Gage bought a new car for $29,000 to use while he's away at college. The car decreases in value by 11%. If he plans to sell the car once he graduates in 4 years, what will the value of the car be? So this is another exponential equation. Let's turn this around. So we're going to start with that model, that template. A, B to the X. This is my starting value. He bought the car for $29,000. It decreases in value 11%. So instead of writing 1 plus 11, we're going to do 1 minus 11%. And 11% as a decimal is 0.11. 11 divided by, remember percent's always out of 100, so 11 divided by 100 is 0.11, which if I was doing this, I probably wouldn't write it like that. I would just in my mind say, okay, that's 0.89, but I want to make sure you know where that's coming from. So we want to know the cost or the value of the car if he's going to graduate in 4 years. So we're just going to plug in 4 for X. So that is $18,195, and we'll round that off to 25 cents. So once you've got the hang of this, once you remember, oh, that's the starting value, that's the increase or decrease, you're going to be fine. These are not difficult. It's just a matter of remembering what everything represents. Okay, last problem for today. If Miss B and Miss D are writing problems for an algebra book, Miss B started with 10 problems already written, and she can write 6 problems an hour. Miss D had no problems written, but she writes 10 problems an hour. So you should see that this is a linear equation because you've got a set amount that they're increasing by each hour. That's going to tell you, okay, this is linear. When will Miss D have the same number of problems written as Miss B, and how many problems will they each have written at that time? Okay, so B started with 10 problems already, and then she's writing 6 problems an hour. So her equation is going to be 10 plus 6x. Miss D, she didn't have any problems written, but she writes 10 problems an hour. So D writes 10 problems an hour. When are they going to have the same amount? Well, let's just set these two equations equal to each other. Here's D, here's B. Let's solve for x. We've got x's on both sides of the equation. I always recommend getting rid of the smaller one, not that you have to. 6 is smaller than 10, so I'm going to subtract 6 from both sides, 6x, and that's going to give me 4x equals 10. I'm going to divide both sides by 4, and x equals 5 over 2, 2.5. So at 2.5 hours, they're going to have the same amount of problems. How many problems would that be? Let's just plug in 2.5 into either one of these. If I plug it in right here, then Miss D at 2.5 hours would be 2.5 times 10, just move the decimal point 1 to the right, 25 problems. So after 2.5 hours, they'll have the same amount of problems, and it would be 25 problems.